Here we're starting on a brand new unit. It's all about polynomials and factoring. So this is what you are going to be hit with when you go straight into Algebra 2. So next year you'll take geometry. The year after that you'll go to Algebra 2. And this is pretty much your beginning point. So we're talking about polynomials, which you already know. Poly means more, and we've already talked about a monomial, which means one term. So poly with more is more than one term. So that is your definition of a polynomial. It is an expression consisting of more than one term. And you can go, like a binomial is 2 terms, a trinomial is 3 terms, and a polynomial is just the overall definition of more than one term. So some examples you have here are 2x squared y plus 3x. Notice it's a polynomial because these can't be combined. They don't have the same ending, so we can't combine them. Another example would be 3x squared plus 4x minus 5. Another one would be 4 plus 2x. They're all just more than one term that can't be simplified. Standard form, so now there is a specific way how we write a polynomial, and that is it must be written in alphabetical order, highest exponent first. That may not make a lot of sense, so let's go through some examples. Here we have number 1. The variable that we're looking for is, or that we're working with, is x. But the specific order is the highest degree first. So I would say 2x squared plus 3x plus 1. Your constant term will always be last. Number 2 would be read 7k cubed plus x squared minus k plus 64. You'll notice we're only working with one variable, but it goes cubed, squared, into the first term. So alphabetical order, greatest degree first. Number 3 is w to the third plus 5w squared minus w plus 28. Number 4, negative n cubed plus n plus 24. And again, notice your constant term is always last, greatest degree first, and then down the line. Now, look at number 5. You've got an A and a B. And so it's alphabetical order. That supersedes the degree. So I'm going to start here with a cubed, and I'm only looking at my a's. Then I'll let the b's play out. So it's going to go a cubed plus 5a squared b squared plus 2ab minus 2b cubed. So even though b is to the third power, I have to get rid of my alphabetical ordering first. So that sometimes causes problems. So alphabetical order, greatest degree first. So a cubed, then a squared, then a, and then I look whatever's left over after a. So number 6 would be greatest degree, alphabetical order, c cubed minus 7c squared d squared. Then I do 5d cubed plus 13. Okay, so those are some examples of polynomials in standard form. So on your homework from here on out, if it's not written in standard form, it's minus half off because it is an expectation that that is how you write it. All right, now, when we start naming polynomials, we name them by degree and number of terms. So think back to triangles. You can name a triangle by its sides and its angles. Same thing with classifying polynomials. You name it 2 ways. You name it by its degree and you name it by its number of terms. Now, some of you guys may be saying, what is the degree? That's just the exponent. So on here, if you have a degree of 0, that means we're working with a constant term. Okay? If you have a degree of 1, it's linear. And I want you to think about y equals x. We've talked about the parent graph before. But when I graph this, the graph of y equals x, I'm going to draw right over here, looks like this. My beginning point 0, my slope is 1, up 1 over 1. So my line looks like this. So x is to the first degree, but what does it make? It makes a linear equation. So it's a line. So when you think degree first, think linear. When you have y equals x squared, that's a quadratic. And the parent graph of a quadratic looks like this. It makes a parabola. That's the shape. So that's a quadratic. X to the second degree. So the second degree is quadratic. When you have y equals x cubed, that's a cubic function. And a cubic function on a parent graph looks like this. So when it's to the x to the third degree, it makes this shape, and that's called cubic. When it is to the fourth degree, that's quartic. And a quartic parent graph, quartic looks like this. Okay, so basically the degree is talking about what does the shape of your graph look like. So when you think of degree, if it's to the x to the first power, it's linear, squared is quadratic, to the third is cubic, to the fourth is quartic. So I'm going to leave those on there so you can put in your notes because that's pretty helpful when you get the picture for it graphic-wise. When it talks about the number of terms, you already know this. When it's a one term, it's a monomial. When it's two terms, it's a binomial. See, this is where your Latin comes in handy, even though it's a dead language. 3 is a trinomial. And 4 is the polynomial. That's 4 and up, we refer to as polynomial. So if I asked you to name these real quick, this would be a constant monomial. Number 8, this would be a linear monomial. Because if I graph this, if I graph that, my beginning point 0, my slope is up 2 over 1. So it looks like that. Number 9 is a linear binomial. And if I graph that, my beginning point's 1, my slope is up 7 over 1. So that's a linear binomial. Number 10, that because it's to the squared power, I know it is going to be a quadratic. 3 terms is trinomial. Because it's to the third power, it is a cubic binomial because it is 2 terms. Cubic because it's to the third degree, binomial because it's 2 terms. Here I have 4 terms, polynomial. The degree is 4, so it is a quartic polynomial. All right. When we look at this, all we're doing when we add and subtract polynomials is what we've been doing all year long. We are just combining like terms. That's it. It doesn't get more complicated than that. If you have an addition sign, nothing changes. I still distribute that addition sign, but my signs don't change. So when it's addition, there's not a lot of work I need to see here. I'm just going to combine those terms. I'm going to go in order, so I'm going to start with my greatest degree. So I have a negative x squared and a 2x squared. A 2 and a minus 1 would be x squared. Here I have an 11x and a negative 5, so I have positive 6x, and then my constant terms are positive 13 and a negative 23, making it minus 10. So greatest degree down, and if I had to name this, it would be a quadratic trinomial, right? Now, if I have a subtraction, I must distribute. So guys, do not do this in your head. I want to see you rewrite it. So I have 4x squared plus 5x. I'm distributing that negative to get minus 7x, minus 3x squared, minus 1. Now I'm going to combine greatest degree first. So 4x squared and negative 3x squared is x squared. 5x and negative 7x is negative 2x. And then left over negative 1. This is a quadratic because it's to the second degree trinomial. So quadratic trinomial. So here are some examples. I'm just going to do, for your notes, I will do these on the left-hand side so you can pause and come back. But when I combine them, it's 5x minus 2. Notice it's written in standard form, greatest degree down. Here I have I got ahead of myself. I have w cubed plus w squared minus 16. That's a trinomial, cubic trinomial. I have negative p squared and p squared, which cancels out, additive inverse. I have 5p and negative 4p, which is p, and an 8 and a negative 15 is negative 7. So that is a linear binomial. I'm going to distribute my negative, so I get x squared plus 17x minus 3x squared minus 5x. And when I combine my like terms, I get x squared and negative 3x squared, which is negative 2x squared. 17x and a negative 5x is positive 12x. So greatest degree down, this is a quadratic because it's to the second degree binomial. Quadratic binomial. All right, 21, I have 4c minus 11. I'm distributing that negative, so I get negative 4c minus 11. My 4c and my negative 4c cancels out. Additive inverse, opposites cancel. A negative 11 and a negative 11 is negative 22. And that is a constant monomial. All right, so I have 7v minus v squared plus 14. Distribute my negative, negative 15, negative 8v, negative v squared. I start with my greatest degree, negative v squared and negative v squared, and I get negative 2v squared. I have negative 8v and a 7v, which is negative v, and my constant terms are 14 and a negative 15, which is negative 1. Greatest degree down, it's a quadratic trinomial, 3 terms. All right, so 25 and 26, find the sum. Sum means addition, so I'm just going to simply add these so I can combine my like terms, and I get 6p squared, negative 2p, that's it, so negative 2p, and then I get a 15, an 11, and a negative 1. So 11 and a negative 1 is 10, 10 and 15 is 25. So this is a quadratic trinomial. Now, highlight 26. Put a star by 26. You will see this on a quiz. You will see this on a test. Make sure, before you start combining, that you write this expression. We are going to turn this into a mathematical equation, an expression. So it's saying subtract from. That's a turnaround word. So we're going to start with w cubed plus 6w squared minus 2. I am taking this term, and it says subtract this polynomial from this polynomial. Well, if I subtract, look how I had to set it up. Now when I read it, does this look like me saying subtract 2w squared minus 5w plus 10 from w cubed plus 6w squared minus 2? Yes, because it's a turnaround word. So now I'm going to rewrite w cubed plus 6w squared minus 2. I have to distribute that negative. Negative 2w squared, negative times a negative is a positive 5w, negative times a positive is a negative 10. So now when I combine, w cubed is my greatest degree, so w cubed, positive 6w squared, and a negative 2w squared is positive 4w squared. 5w, oh, I hate to do this. And then negative 2 and negative 10 is negative 12. So we have 4 terms here. Cubic polynomial. All right, if you have any questions, good luck. Come see me if you have questions.